Good day, ladies and gentlemen, my wonderful viewers. Welcome to another beautiful episode of Mindspring Academy. So, this is also another day to remind you that physics is not a difficult subject. So, stop having that doubt in you that it's actually difficult. No, very, very simple. So, let's look at this topic today. And the topic says equilibrium of forces. Now, a body is in equilibrium when there is no net force acting on it in any direction. The body is therefore not accelerated, thus, the body is either at rest or moving with uniform velocity. Now, let me explain this before I go to the next paragraph. Now, when they say a body is in equilibrium, it simply means there is no net force. And what is net force? Net force simply means F net, that's the formula for net force. F net is equal to MA. Why is it called net force? It's called net force because that is the force that is required to actually make a body or an object to move. Now, assuming this is a body and is on a plane, this someone is pushing towards this direction, and the other person might be going towards the other direction. So now, if I apply force, F net, if I apply force on this body or object, now the next thing you notice is there will be no equilibrium in the object. Now, another thing they said here is pause. The body is either at rest or moving with uniform velocity. What is uniform velocity? Remember your velocity time graph, which says when you have something like this, uniform velocity is like this. When you're moving on a straight line, when you're moving on a straight line, you are not accelerating or you are not decelerating. That is what we mean by an object being in equilibrium or a body being in equilibrium. So when bodies are at rest or they are moving with a uniform velocity, nobody is changing their velocities, they are not increasing and neither are they reducing. It's meant to be equilibrium. So generally, a body is said to be in equilibrium when it either remains at rest. So when this object is at rest and F net has no effect on it, there is no force, net force acting on it, it's said to be in equilibrium. Or moves in a straight line with uniform velocity when an object is just moving on a straight line on its own, just like that. No external force added, nothing. We simply say to be in equilibrium. Now, looking at the types of equilibrium, first one is static equilibrium. Okay, static equilibrium. While the second one is kinetic or dynamic equilibrium. Now, for static equilibrium, when there is no net force acting on a body and the body is at rest, then the body is said to be in static equilibrium. This is quite simple and explainable. Just a body kept maybe on a table or something. Now, this is that your body and this is your table. Now, when a body is at rest like this, just like this, nobody is pushing it, nothing is happening to it, it's just on the table, it's said to be static equilibrium. When something is at rest, by the word static, you know it's rest. Now, the next one is kinetic equilibrium. When there is no net force acting on the body and the body is moving with uniform velocity in a straight line, just like I showed you before in the definition, where we have velocity time graph. Here is your velocity and here is your time. So we have that uniform velocity with which it's moving, that straight line. That's what we mean by uniform velocity. So now they say in a straight line or it's rotating with a uniform angular velocity about a fixed axis through its center of mass, then the body is said to be in kinetic or dynamic equilibrium. Now let me explain this angular velocity. I have a circle here. Now, most of us, while we were still small, we did something very, very funny and interesting. What was that? Someone will draw a circle, stay here, and then the next thing is we can actually divide this circle into four equal parts. Now, here I am, I'm here. Now, there is this point in time when you have to get your rope and you start wearing it around or above your head. Now, that stone with the rope is actually moving at what we call angular velocity W. It keeps moving around the circle. It's consistent. It doesn't, maybe while it's moving circle, it started moving vertically or it started moving horizontally. No. Angular velocity, it's going to keep rotating around the body. Triangular laws of forces. This principle or law states that if three forces are in equilibrium, they can be represented in both magnitude and direction by the three sides of a triangle taken in order. Now, when you see something like this is called triangular law of forces, and how to actually do it is it's going to be in the form of a triangle. It's going to be in the form of a triangle. Now, this is a triangle where you have your alpha 1. Alpha 1 is actually uh, how you can get your alpha. Alpha is gotten by alpha is equal to 180 minus theta. So maybe you were given an angle in the question. So when you do 180 minus theta, the alpha is what you are not going to be writing inside. Now here we have this. I can extend. Where is it coming from? Let me extend it. Here to here is the theta 1, while here to here is theta 2. While here is definitely going to be alpha 2. Here is going to be, sorry, I cannot extend this. So here to here is theta 3, while this will be alpha 3. So whenever you want to get your alpha, it's 180 minus theta, you get the alpha. Alright, now looking at this, they said the principle or law states that if three forces are in equilibrium, they can be represented in both magnitude and direction by the three sides of a triangle taken in order. These thetas, these alphas that you've seen, all of them mean directions. There are some that are actually pointing towards the north, some are pointing northwest, some are pointing towards the east. Let's see equilibrance of forces. Equilibrance of two or more forces is a single force which will balance all other forces taken together. It is equal in magnitude but opposite in direction to the resultant of other forces. Now, what do we mean by that? If it comes to this, in our last video, we saw diagram about scalars and vectors, where here will be your F1 and here will be your F2. Now, if you make your resultant parallelogram law of vector, here to here is going to be your resultant. Mind you, I say the resultant, the line for resultant should come in between the two vectors. It should be in between the two vectors, not here to here. No, these are not the vectors. This is just the completion to make it a parallelogram law. Now trace this down. If you trace this down more, if you trace this down, this is going to be, sorry, this is going to be F3, F3, another vector, F3. Now, why is it F3? You notice something. F3 is acting in opposite, is acting opposite to the F1 and F2. That's what they mean by but opposite in direction to the resultant of other forces. So therefore, with this, we can say note F3 is the equilibrant of F1 and F2. Equilibrant simply means anything that acts in opposite direction to forces you are given, but it has the same magnitude. It has the same magnitude with all other forces that you were given. While R is resultant of F1 and F2. So this R here is actually the resultant of both F1 and F2, but F3 is the equilibrant. Why? Because it's equal in magnitude with F1 and F2, but just that it acts in opposite direction. Please, if you know that what we've been doing have been interesting you and you've been getting so many things from what we've been doing, help me to subscribe, like, and share to others who might be in need of it. Alright, now looking at the triangle law of forces, this is actually a typical question that can be given to you. Now the first thing you need to do is to actually see to it that yes, you resolve these three forces, you resolve the three of them into a triangular form. Now let's see how possible that will be. Now I can have this, I can have this, and what am I drawing for? I'm actually drawing F1, so I'll call it F1. I hope you can see what I'm doing. Now go over to this. If it comes to this place, we can draw it like this. and draw it like this. Look at the direction where it's acting. I don't need to do it like this. That's not where it's acting. It's acting towards this direction. I'm going to do this. Now look at this. Look at this. The direction is going down. So I'll move it down. I'll try to extend the arrows because they have theta's at which they were inclined. Alright, now let's see this. Now if I come to this F1, here is going to be my theta 1. Here is going to be, this is F3, mind you, and this is F2. Remember, F2 is going towards this direction. That is why I had to do this for F2. I had to do this. Place it towards direction for F2. Now coming to this, I have here, I have theta 2, and finally here, I'll have theta 3. Now, if you look at these respective forces that I have actually resolved to look like a triangle, the thing is, we can actually give them angles inside. There can be an angle here. Remember that sum of angles on a straight line should be giving you 180. There should also be an angle here. There should also be an angle here. Now, how do we find these angles? Remember I said something earlier on. I said alpha is equal to, let's see alpha 1 or alpha 1, yes. 180 minus theta 1. That's how you can get it. While, can you try alpha 2? What is it going to be? Okay, good. So 180 minus theta 2. While alpha 3 is going to be, let's go, 180 minus theta 3. Okay, so now let's go over to this. Here, when I do 180 angle on a straight line minus theta 1, is going to give us alpha 1. Come over to this place, I'll place alpha 2. Here too, I'll place alpha 3. Now, with this, I hope you've heard of sine rule. You should have heard of it, sine rule. Now, sine rule is actually a rule that helps us to resolve respective sides and angles of a triangle. Now, the formula would be F1. Okay, initially, the formula is meant to be, we know it as small a over sine capital A equal to small b over sine capital B equal to small c over sine capital C. But this time around, I don't have all these A, B, and C. What I have is, I have F1. Okay, yes, I have F1. Let me take my A as F1. So here I can write small letter A. Small letter A. It's meant to be alpha 2y. The side where the F1 is facing becomes capital letter A. Yes, this capital A, this small a. Capital A is the angle itself, while small letter a is the side which is facing. Now here, if I come to the next one, equal to, I can take B to be F2. So I'll write B there. So can you tell me where will be capital letter B? Is it going to be here or is it going to be here? Definitely, you should know it's meant to actually be here. Now, if it's here, that means it's actually facing it properly. The angle is facing the side properly. So I'll have F2 over sine alpha. Alpha, what will I put this? Alpha 3. We're going to look at questions on how to actually solve. What we just did is using letters and symbols to actually resolve a triangle. But we'll take a question now. Let's see the question together. Now, here is example 1. And example 1 says, two strings each inclined at an angle of 30 degrees to the horizontal are used to hold a bucket of water weighing 20 newton. Calculate the tension in each string. Now, before I solve this question, you just have to do something for me. Click the subscribe button, like, share, and share to your friends who actually need this video before I even solve and tell you the trick on how to solve this. Remember, I talked about trick on how to actually make physics simple. Like I said, physics is very simple. Now, from my diagram, I can have something like this just to represent the statement I have. Now, they said this and this. I have a bucket of water. I have a bucket of water weighing 20 newton. Now, what do you mean by tension? Tension simply means a rope or string attached to lift an object. So I can decide to call here T2 and I'll call here T1. These are the two tensions that are trying to hold a bucket of water weighing 20 newton. Now, but they said something. They said two strings each inclined at 30 degrees to the horizontal. When you hear the word to the horizontal, please, it's always like this. The angle must touch your horizontal, not the vertical part. So here I write 30 degrees. Here also I have 30 degrees. Now I want to show you a trick, but I believe you have clicked the subscribe button. So now look, this is the trick. Now anytime you're solving questions on tension, before you resolve it into your triangle, that's when you want to resolve, you must make sure you have the vertical component traced downwards. Look at this, where I'll have this and I'll have this meeting up. Now here, I'm going to have angle 60 degrees. I believe you know why. Because this is forming angle 90. It's forming angle 90. So when you do 90 minus 30, what will be left out is 60. Come over to this place again. We're having angle 90. Now when you do 90 minus 30 again, you'll be having 60 degrees. Now if you have the 60 degrees and you want to draw your triangle, this is the rule in drawing this for equilibrium. Now you see this line on top is the same thing as this one pointing downwards. So I can draw my triangle like this. I'll take this like this and I'll take the other one like this. Now here will be my T2, here will be my T1. I'm taking the directions just the way I'm seeing it. That's what I'm doing. So with this now, I'm going to write this. If you look at your arrow very well, you notice the way it's pointing. It's pointing like this. So we'll have our arrows like this. So with this now, I have here being 120, sorry, 20 newton, which is pointing downwards. Remember, the weight of an object always acts downwards toward the center of the earth. Now, looking at this, I will fix in my values very well. Now, fixing in your values very well, you should know that this T2, you have 60 degrees when you've resolved it vertically. So I'm going to be placing 60 degrees here. That's for the T2. Come over to the other one. Now, if you come to this one, T1 is having something in common with 60 degrees. Also place the 60 degrees beside the T1. I hope you get what I'm doing now. Now, look at this diagram very well. In a triangle, what's the sum of angles we have in a triangle? Is 180. So here is 60, here is 60. When you add it up together, you get 120. Am I right? Okay, so how do we get this part? How do we get this? What value are we going to put here to make it a complete angle in a triangle? So it's going to be 60 degrees as well. It's going to be 60 degrees. Now let's see how we can solve this. Remember, using your sine rule, so I can actually say this is 20, where the angle that is facing the 20 is 60 degrees. So I'll be writing 20 over sine 60 degrees is equal to, let's see the next one. This is 60 degrees. I'm looking for T2. Let me look for T2. Remember they said calculate the tension in each string. This is T2. So I have 60 T2. I'll write T2 over also sine 60. Now when you cross multiply, we have T2 sine 60 degrees is equal to 20 sine 60 degrees. If you divide both sides by sine 60 degrees, this will cancel this. Therefore, T2 is equal to, let's see T2. Can sine 60 cancel sine 60? Yes, perfectly it can. So we have 20 Newton. Now this T2 being the tension for 20 Newton. We can also find T1. But let me just give you a trick again. You don't need to stress yourself. If you look at this is called an equilateral triangle. All sides are equal. So whatever value that you put in T2, which is 20 Newton, you must also put the same for T1. Why? All angles are equal. One properties of an equilateral triangle is all the angles are equal and also all sides are also equal. So once we get 20 as T2, meaning the correct answer to my question is going to be option B. Okay, now this is a perfect example coming from also the topic equilibrium of forces, and here we have a diagram. A string is attached at one end and it's used to lift up a load of 250 newton, another string T2 also on tension. The diagram illustrates three forces T1, T2 and 250 newton in equilibrium, and it says calculate the magnitude of T2. We have options given. Now, if you come to this diagram, remember I told you something. I said, whenever it comes to anything tension, you have tension, you must make sure that your angle is resolved into the vertical component, not the horizontal. So you don't use the horizontal to solve questions in tension, but you use the vertical ones. Now look at this. If I have an angle here, I didn't have it, but if I have an angle here, can you tell me what your mind might be telling us to put there? What value? If you notice, it's going to be 60 degrees. So this 60 degrees is the one that is inclined to the horizontal. It's inclined to the horizontal. It's moving to the horizontal. That's what I mean by inclined to the horizontal. But if you look at your 30, which was given to you in the question, you notice that it is inclined to the vertical. Now, if I want to use this and solve, it's very simple. All I need to do is create my diagram just like the way it is in the vertical. I have something like this. Here will be pointing downwards and I will use it as my 250 newton. So I can be writing here 250 newton. Remember I said the weight of a body always acts downwards. So if you come to this, this is 250 newton. The next thing is you have this, which is your T1, and what do we place here? Can you try? Okay, it's remaining only T2. T2 is the only thing we can actually place. If you watch the direction T2 is also going, you notice it's going towards this direction. So this becomes our T2. Now let's go back to the question. I have 30 degrees. Let's go back to the question. They say we should calculate the magnitude of T2. Now where is T2? This is T2. So in using, I would say using trigonometric ratios, which you know them, it is SOHCAHTOA. So let's see how it goes. Now here, if it's T2 you are looking for, therefore you must be making use of T2 and a value that has been given. So where your angle is facing is called opposite, and this will be your adjacent, while this where your right angle triangle is facing is called hypotenuse. So according to what I'm asked to find, magnitude of T2, what should I be using? I should be using opposite and adjacent. So with this I have tan 30 degrees is equal to, that's why I have to use TOA, opposite over adjacent. So opposite is T2, I'll write T2 over, my adjacent is 250, I'll write 250. When I cross multiply, I'll be having, therefore, T2 is equal to 250 times tan 30. 250 times tan 30 degrees. Now T2 is equal to, now 250 times tan 30 degrees. Now looking at my options, you notice something. It was given in decimals, but sometimes they might leave it for you in short form. So here in decimal, we'll be doing 250 times, what is tan 30? Tan 30 is 0.5774. Yes, so equal to, when you multiply this, you're going to be having 144.35 Newton, and that becomes your answer. I hope this is clear and understood. Remember, rules, it must be the angle on the vertical that you will be using in your tension. You don't use the one that is at the horizontal. Another example, it says an object is held in equilibrium. This should be the third example, number 3. An object is held in equilibrium as illustrated in the diagram. Using the data, determine the magnitude W of the weight of A. Now this is an object A, but it has a weight which is lettered W. Now if it comes to this, you notice there is an angle that was also given. But this time around, this angle is straightforward. It's not a given angle. It's actually a right angled triangle. So if I decide to bring this out, I'll be having something like this. I'll have a right angled triangle. I have a right angle triangle. So if you have a right angle triangle, the next thing is you put your angle 90 degrees, and then we have here this line. If you watch it very well, that's why I represented it. This line is going to be the 15 Newton, while here is going to actually be the 8 Newton, just according to the diagram. And here becomes your hypotenuse. So now I have this. Let me call it W. If you remember this one going here, it come on top. I said this before in the last class. So we have W. Now, if you are looking for W and you have an angle 90, the best thing to use is solution. Use Pythagoras theorem. Now, Pythagoras theorem says hypotenuse square is equal to opposite squared plus adjacent squared. Let's put it together. Here is going to be the opposite, here is going to be the hypotenuse, and here is going to be the adjacent. Now when you do this, your hypotenuse is W, so I'll put W squared is equal to 15 squared plus 8 squared. So with this we have W squared is equal to, what's 15 squared? 15 squared is 225. Yes, 225 plus the next one is 8 squared. So 8 squared is going to give us 64. When you add this, we'll have W squared is equal to 225 plus 64. That's going to give us 289. Yes, it's going to give us 289. So if you look at it very well, the next thing to do is square root both sides. Square we cancel square root. Yes, quite alright. Square we cancel square root. And then we have therefore W is equal to the square root of 289 is going to be 17. So I put my 17 Newton and that becomes my answer, option B. Now here is a question from JAMB, and from the diagram below, a weight W is equal to 60 Newton is suspended horizontally by a string attached to a wall. Find the tension T on the string. Option A 60 sub 3, 20 sub 3, 40 sub 3, 120. JAMB 2017. Now come on with me, let's solve this together. If you look at this, it's quite confusing. That is one thing JAMB do. JAMB will actually try to make questions confusing in a way so as to confuse you. At the end of the day, when you pick an answer in the option and it's not the correct one, you see students coming out of the hall shouting ta and adding bad. You know what I mean by that. Now let's see this. If it comes to this, the first thing you need to do is ensure you resolve. Remember the rule. Is it on the vertical or the angle? Yes. So I'll just take it down. What I'm asked to find is the T, which is this tension. So I'll do this. Here I have 30 degrees. And here, what is acting downwards? Remember, when something is acting downwards is the weight. So I'm putting 60 Newton there. And then here, I'll be having this F. That's my F. But if you look at the question, they say find the tension T. Nothing concerns you with the F. If it's the F they ask you to find, then we're going to be using the F. But mind you, here is going to be opposite. Why? Because that's where the angle is facing. Here will be hypotenuse, and here will be adjacent. Now let's do it together. So here 30 degrees, I'm going to be using adjacent and hypotenuse. I'm using adjacent and hypotenuse from your SOHCAHTOA. Adjacent hypotenuse. So therefore I'm using cos theta is equal to, let's see it together, cos theta is equal to adjacent is 60. So I'll write 60 over, let me do it like this. I'll write adjacent over hypotenuse for clarity's sake. Adjacent is 60, so I'll write 60 over my hypotenuse is T. So to find this now, what I'm going to do is I have cos 30, so I'll bring it down. Cos 30 degrees is equal to, that's my angle given, is equal to 60 over t. So I will cross multiply. You cross multiply, you'll be having t cos 30 degrees is equal to 60. To get your t, you need to divide both sides by cos 30 degrees. Divide here 2 by cos 30 degrees. So this can cancel this. Yes. Therefore, t is equal to, let's see it together, t is equal to 60 over, what is cos 30? Cos 30 is actually 0.8660. So I can decide to put it 660. So when you divide, we have, sorry, cos 30, we are asked to leave it in sort form. If you watch your options, you notice they are in sort form. So cos 30, I'll write 60. Cos 30 is actually divided by sort 3 over 2. So 3 over 2. So I have t is equal to 60 times 2 over sort 3. I hope you know why I wrote over sort 3. Okay, let me take it up a little. Let me take it up. So here I'll have t is equal to 60 divided by cos 30 is sort 3 over 2. So I have t is equal to, can we change division to times? Yes, we can. So 60 times 2 over sort 3. When you multiply, you'll be having 120 over sort 3. Now 120 over sort 3, it's not the best thing to write. What is the next thing to do? You rationalize. It's not good for denominators to carry sort. So we rationalize, multiply both sides, the numerator and denominator by sort 3. Finally, we are going to be having, this is 120 times sort 3, yes. Then sort 3 times sort 3, that should be giving us sort 9. But square root of 9 is what? Is it not 3? So when you have your 120, you have your 120 sort 3. You have your 120 sort 3. If you divide it by the 3, you notice that 3 will go into 20 and that will give you 40. So we are left with 40 sort 3. Looking at the option, the correct answer is meant to be option C. But do you know that when you make mistake and try to mix this up, not using cos theta, maybe you went ahead to use sin theta. Are you aware that your answer is also going to be in the option? Bad. Now, this is going to be the last question we're going to be taking on equilibrium of forces, specifically triangular law of forces. So please do well to subscribe, click the notification bell so that you can be updated on when we upload new videos. Now, with this, we have, for what value of theta are the forces in the diagram in equilibrium? A 15 degrees, B 30 degrees, C 45 degrees, D 60 degrees. Now if you look at your diagram, this diagram we have here, now the theta that you are asked to find is actually to the vertical. Then fine and good, I don't need to do any subtraction again by 90. So what I'll do, I will bring it down. I'll have this, now I'll have this is this, and this one is going down. Okay, let's see this together. So this here is going to be 12 Newton. Here is going to be the force acting downwards, like I told you. It's meant to be 6 Newton, while this going towards the east direction is 6 sub 3 Newton. So if you put your angle, which is theta, and you try to represent where the angle is facing, is called opposite. Here is hypotenuse and here is adjacent. So let's proceed. So if I want to look for my theta, I can decide to use anyone since all the three sides are given. Quite alright. I can use anyone. So but I would like to use adjacent and hypotenuse. Yes, just my decision. If you do also with opposite and hypotenuse, you will get the same answer. Now let me use adjacent and hypotenuse. The reason being that this and this, these are the two lines of the triangle where the theta is inclined to. So I decided to just use it. But if you try this out, you still get the same thing. So with this, I have here adjacent hypotenuse. Adjacent hypotenuse, that should be cos theta equal to. So my cos theta is equal to my adjacent here is 6 over 12. And when you do that, we have cos theta is equal to 0.5. Why? 6 divided by 12. 6 here is going to give you 1. 6 in 12 is going to give you 2. So 1 over 2 is something as 0.5. So how do we find theta? Please, theta is not gotten by saying theta equal to divide both sides by cos. No, we don't do that. So theta is equal to cos inverse of 0.5. So what's the cos inverse of 0.5? Theta is equal to 60 degrees, which is option B. That is my answer. Alright, thank you and remain blessed. Don't forget to click the subscribe button, share the videos, and also like it. Thank you. So I'm going to drop a question which you can actually try on your own. I'm going to drop it now so you try it and put down your answers in the comment section so that I can see it and verify. Thank you.